Question 4. There's two methods to complete this question. I'll show you both ways. The first and easiest way to do this problem is using conservation of energy. The second being resolving the forces acting on the mass, then using the equations of motion. Here's a simple diagram of the problem. I've got the slope at 28 degrees and the initial velocity u of the mass at 3 meters per second. If we ignore friction, the law of conservation of energy tells us that the total mechanical energy of the ball remains constant. Initially, all of the energy of the ball is kinetic. We're interested in the final position of the ball when the kinetic energy equals 0. But the law of conservation of energy will be true for the ball in any position. So the law of conservation of energy lets us say that the initial kinetic energy of the ball is equal to the final gravitational potential of the ball. This is because all of the initial kinetic energy is transformed into potential energy. Writing down the formulas for kinetic energy and gravitational potential energy, we see that the mass of the ball here can be cancelled out. Making h the subject, we get u squared on 2g. This tells us that the height that the ball reaches above the ground h is 0.46 meters. To solve for the distance the ball makes it up the ramp, if I call that s, we need to use sine theta. Drawing the appropriate triangle and solving, we find that the mass travels nearly a metre up the slope. Now the other way to solve this question using forces is using the fact that the net force on the mass will be mg sine theta. If you want to know where this relationship comes from, I suggest you watch the inclined plane video. If we're going to use our equations of motion to solve this question, we need to identify a positive direction. So I'll let positive be up the slope. Initially the ball then has a velocity of plus 3 meters per second. The final velocity of the ball will be 0 meters per second, the position where it reaches the furthest up the ramp. We want to solve for the displacement of the ball at this position. And using F net equals mg sine theta, we can calculate the acceleration of the ball down the ramp. Solving gives us an acceleration of 4.61 meters per second, which is going to be a negative value in our coordinate system. Writing out what we know and what we want to find out, we see that the equation of motion we want to use here is v squared equals u squared plus 2as. Making s the subject, we get that s equals v squared take u squared divided by 2a. Subbing in and solving, I find that the displacement up the ramp achieved by the ball is 0.98 meters.